For all your heating and cooling needs, you need endless energy.
The huge setbacks that we do when we turn off the system, or if we turn it down just a couple of degrees, sometimes that equipment needs to run a lot harder to make up that temperature difference. So if I leave my house and I turn it down, my temperature down, like especially right now it's 30 degrees outside or colder, I come back to my house and it's 65, but I want it to be 70, it can take 2 or 3 hours for it to get back to that temperature. Over time, that actually can drive up costs for energy use, especially with newer technology that's designed not to run as hard. We get into these efficiency principles and discussions, and a lot of people think money or savings, and yes, that's mostly true. There's some truth to that, but what we're really looking at is, for example, oil or gas versus electricity usage. So if I were to use therm as a form of measurement for gas, right? So for each therm, how much of that am I actually using as heat for my home? I have a 90% efficient boiler. That means automatically at least 10% of the gas that I'm burning is actually going out my chimney, right into the air. When we set a system down like 5 or 6 degrees, or even more, some people do. Some people turn it off when they go to work, and then they turn it on. Even if they turn it on before they come home, we have all these new Wi-Fi thermostats, so people can do that, and that's some of the reason why they do that. They think they're saving their energy bill. Well, your whole home temperature drops 5 to 10 degrees or whatever it ends up getting to. We're not just heating the air in a home, we're heating every piece of furniture. We have to heat the walls. So it takes a lot more time and a lot more energy to bring a house up to that desired temperature if we let it go down. If we go back to the efficiency of a system, the inverter technology that we're using allows us to put in systems that now, basically like driving a car, if you're driving in the city, you're going to use more, whether you have an electric vehicle or you have a gas-powered vehicle, you're using more energy to start and stop the vehicle. It's just physics. And so we look at this, and with this new inverter technology, basically we've put transmissions in every single system that's out there now. So really they want to run in cruise control at a specific speed, and they use whatever factors, algorithms based off of outdoor temperature, indoor temperature, getting back to the system, to basically decide how much energy or how much gas that you need for your throttle. So if you're keeping your system set to the same temperature, it's just trying to maintain it, which means it could be running as low as 10% of its total capacity just to keep the home warm, which drives down your energy costs significantly because the compressor is designed to not have to go at its full maximum speed, just like your automobile. It's not designed for you to always press the gas all the way down to the floor. It's not meant for that. It wants to kind of just cruise along, and then it uses a lot more of that fuel to move faster if we need it to accelerate essentially. With this heat pump technology, it's going to, once it hits that desired temperature, it'll actually continuously run. That's what we want it to do. We want it to just stay at that temperature, and this does help with comfort. If you want your house to be 70 degrees and you set it for 70 and you walk away, yes, that system's running, but it's going to slow down. It's going to barely run. You're hardly going to feel it. In a lot of cases, you may not even hear it so much because it's just keeping up. Whereas when you turn it on and it has to go back up to that 5-degree point, it's the fan's blowing at full speed, the compressor's running, it's vibrating the house in the middle of the winter. It can cause some other discomfort other than just temperature. So as far as comfort goes, it's comfort. It's, in most cases, for most people, it's better energy usage. So it's, better energy bills in the middle of the winter when you're running it for heat. The middle of the summer, you're going to notice a huge difference for sure in the summer versus an old traditional AC only system that just comes on at 100 miles an hour and just stays running at that speed, versus just coming on and basically cruising along and barely needing to use the total energy that it can use. how I would explain it to a customer is, or to anyone really, is just when with your new system that you're getting put in, and even the old system that might be 10 or 20 years old, you'll probably see a similar result, even if it's gas or oil, that you really want to keep it there. And yes, you may not necessarily see immediate savings, right away, but as you draw that out over the course of like the season, you more than likely will see a small improvement. And it all depends on like other factors in the home and everything. And I don't know, there's no easy answer that fits every single person out there. And there are a lot of people out there I've had this conversation with that will just go and they'll use those setbacks. But most of the time that I've told people that have used it, they find that it works significantly better. And they're very grateful that they've made the choice to move away from setbacks.
For all your heating and cooling